Okay, now what we're going to do now, we're going to do non-uniform circular motion. Okay. Now, just let me give you an example. Okay. Now, say if I have a hill, a little pump on the road, okay, on the ground. Now, then I'm going to roll a ball around it. Okay, so if I roll this object, if I roll this ball um, really fast, okay, if I roll this ball really fast, okay, it will move forward, okay, move on the hill, move on top of the hill. If it's really fast, it will fly away. Okay, you can try that uh, at home. Okay, it will fly away. Okay. This is when it's really fast. Okay. However, if I'm if I roll this ball a little bit slower, if I roll this ball a little bit slower but reasonably slow, so it still come on top of the hill, then it will roll down. It will keep in contact. Okay, now it will roll down. Okay, it will keep in contact with uh, the ground. Okay, so that's a little bit slower. Okay, now the question here is, okay, now how fast? The question here is how fast I can roll the ball so it starts to fly, okay, after passing through the hill. So that's the question here. How fast? How fast? Okay. So the ball would lose contact with the ground. Okay. Now if we go to um, yep. So the idea is we assume this hill is in circular motion. Okay, it's a circle. It has a radius of r. Okay, so because it moves vertically, okay, the ball is moving vertically. It experience well, the ball moves horizontally, but it experiences a vertical force. So it's a non-uniform circular motion. It is not a uniform circular motion anymore. Now, let me just okay. Now let's do a detailed analysis, okay, on the forces of the ball, okay, when it's on the hill. Okay. Say I have a hill. Now I have a ball here with a mass of m. Okay. Now the radius here will be r. Now let's draw a force diagram on it. Okay. Now first thing, I will have the force of gravity. Okay. The mass force, the gravitational force, mj, acting downwards. I would have the normal force acting upwards. Okay. Again, okay, since it's a circle, since the ball moves the velocity moves this way, okay, there will be a centripetal force. Okay. So the centripetal force is again towards the center of the circle. So I label it FCP. Now what you have to remember in this case is the centripetal force. The centripetal force is always the net force in this situation. Okay, so let's write down an equation using Newton's second law. Okay, so the sum of all forces is net force. Okay, so my net force will be my centripetal force equals to the normal force take away, because it's, well, centripetal force is in minus direction, it goes down. Okay, this is positive. Okay, will be my normal force take away the weight force. Okay, so what's happened is, okay, now note that the normal force is here. Okay, now if the normal force is, say, is less than 0, okay, if the normal force is less than 0 or equal to 0, it means, it indicates, okay, the ball, the object, in this case the ball, is losing contact. Okay, it's not it's losing contact with the ground. Okay, so if yep, so what's happened is, if we rearrange the equation, my normal force will be my weight take away the centripetal force. Okay, now let's rewrite the equation. Okay, the centripetal force is mv squared divided by r. So when n equals to 0, okay, the ball flies away. The ball loses contact with the ground. Okay, so if we put that in the equation, okay, for the point, and we try to solve it, we can try to rearrange it. We try to rearrange the equation. Okay, m cancels out. V squared equals to rj. Okay, v will be square root of rj. Okay, then we put down a value, then we will have, this is the minimum speed for that ball to, at that point, to be fly away, to lose contact with ground. Okay. This is a example for, this is an example for non-uniform acceleration. Okay, so please copy down this formula in your book, and in VCE you are expected to do all this by yourself in the final year exam. Okay, so what the examiner was looking for is, the examiner, okay, is looking for this. Okay, you need to be able to write down this equation. Okay, the key to do it is just remember your centripetal force, okay, is basically your net force. Okay, so your net force is the sum of all forces. Okay, so you need to be able to derive this equation from here. Okay, then afterwards you can use this. Okay, well, this equation is not recommended, but it works. However, if you just write down this equation in the exam, okay, they give you 0 marks, because you're not able to derive it from So yep. Okay, so let's do some examples.